Hello everyone, welcome to Last Bench Students. In this video, we are going to learn Relational Database Model, one of the most important topics in database management systems. Let's understand this topic in a simple, clear, and exam-oriented way. Let's get started. Before we begin, let's look at the learning objectives of this video. In this session, you will learn the Relational Database Model, its characteristics, components, keys, advantages, disadvantages, real-world applications, and a quick summary for exam preparation. Let's begin with the basics. Let's begin by understanding what a database model is. A database model is a collection of concepts used to organize, store, and manage data efficiently. It defines how data is stored, how different data are related, and how information is retrieved from the database. Now let's move on to the Relational Database Model. Now let's understand the Relational Database Model. A relational database model stores data in the form of tables, also called relations. Each table contains rows, known as tuples, and columns, known as attributes. Different tables are connected using keys, making data storage organized, accurate, and easy to retrieve. The Relational Database Model was developed by Dr. Edgar F. Codd, who is known as the father of the Relational Database Model. In 1970, he introduced this model at the IBM Research Laboratory in San Jose, California. His idea of organizing data into tables and defining relationships between them revolutionized modern database systems. Now let's understand the basic structure of a relational database model. Every table is made up of 6 important components: relation, tuple, attribute, domain, degree, and cardinality. Together, these components help organize data in a structured, accurate, and easy-to-manage format. A relation is simply a table used to store data in a relational database model. Each relation has a unique name and contains data arranged in rows and columns. In this example, the entire student table represents one relation. All database operations are performed on these tables to organize and manage data efficiently. A tuple is a single row in a table that represents one complete record. Each tuple contains values for all the attributes of a particular entity. In this example, the highlighted row stores the details of one student. A table can contain multiple tuples, with each row representing a different record. An attribute is a column in a table that describes a specific property of the data. Each attribute has a unique name and stores values of the same type. In this student table, student ID, name, department, and age are all attributes. Attributes help organize data in a meaningful and structured way. A domain is the set of valid values that an attribute can accept. It defines the type and range of values allowed for a particular attribute. For example, the age attribute may allow values from 18 to 60 only. Any value outside this range is considered invalid, helping maintain data accuracy and consistency. Cardinality describes the relationship between two entities by showing how many instances of one entity can be associated with another. The 4 common types of cardinality are one-to-one, one-to-many, many-to-one, and many-to-many. Understanding cardinality helps us design efficient databases and maintain proper relationships between tables. Let's understand the ER model with a simple student course example. The ER model represents entities and the relationships between them. Here, student and course are the 2 entities, and the relationship is enrolls in. One student can enroll in many courses, and one course can have many students. Therefore, this is a many-to-many relationship. Let's understand the ER model with a simple student course example. The ER model represents entities and the relationships between them. Here, student and course are the 2 entities, and the relationship is enrolls in. One student can enroll in many courses, and one course can have many students. Therefore, this is a many-to-many relationship. The relational database model offers several advantages that make it widely used in database systems. It is easy to understand, reduces data redundancy through normalization, maintains data integrity, supports fast data retrieval using SQL, and provides better data security through access control. These advantages make it reliable and efficient for managing data. Although the relational database model offers many advantages, it also has some limitations. Complex joins can reduce performance, the schema is fixed and difficult to modify, and scaling large databases can be challenging. It is also less suitable for handling unstructured or rapidly changing data. The relational database model is widely used in many real-world applications. It is used in college management systems, banking, hospitals, e-commerce platforms, and library management systems. These applications rely on relational databases to store, organize, manage, and retrieve data accurately and efficiently. Let's quickly summarize what we have learned. The relational database model stores data in tables using relations, tuples, and attributes. Keys help connect tables, while the ER model represents relationships between entities. Finally, normalization reduces data redundancy and improves data integrity, making the database more efficient and reliable. Before ending this session, let's look at some important university exam questions. Practice these questions regularly to strengthen your understanding of the relational database model. Focus on definitions, characteristics, ER model, cardinality, keys, and diagram-based questions, as they are frequently asked in university examinations. Thank you for watching. Keep learning. Keep growing. Wishing you all the best. Thank you.